We want to solve this system of equations. So let's call them 1, 2, and 3. And straight away I can see that I can eliminate y from 2 and 3. So I'm going to go ahead and do that by doing equation 2 plus equation 3. And that's going to give me 5x's. The y's are going to go. I'm going to get 4z's. And I'm going to get 11. So I'm going to call that equation 4. And then I'm going to do equation 1 plus twice equation 2, which will also get rid of y's. So 2 of these is 4x and 1 is 5x. And then 2 of those is 4z, add negative 3z, so that's just plus 1z. And then we've got 12 and 2 gives me 14. Call that 5. And let's do 4 take away 5. So the x's will go now, and I've got 3z equals negative 3, so z equals negative 1. So substitute that in 4, and I'm going to have 5x's take away 4 is 11, so 5x's are 15, x is equal to 3. And let's now go to equation 1, and that's going to give me 3, add 2 y's, now z is negative 1, so that will be plus 3 equals 2. 2y plus 6 equals 2, 2y is negative 4, so y is negative 2, and so finally we have x is 3, y is negative 2, z is negative 1. We now have another system of equations. We want to find the values of k and q such that there's no solutions to the equation, there's infinite solutions, and there's a unique solution. So we're going to start by eliminating things, as we do normally. And once again, look at the y's. So I can do equation 2, add equation 3. And that's going to give me 5x's. The y's are going to go. And let's think about the z's. So if we're adding these, that's going to be 2k take away 3. So I'm going to have 2k minus 3 z's. And that's going to give me 15 plus q. And once again, if I do equation 1, add 2 lots of equation 2, that's going to get rid of y. So that's going to give me 5x's. And let's think about these z's. So I'm going to have minus k squared z and plus twice k take 1 z's, and that's going to be equal to 2 of these, so 12 plus 2q plus 2, so that's going to be 14 plus 2q. So I need to tidy this lot. So we're going to have z into 2k take away 2 take away k squared is 14 plus 2q. So I'm going to call this one 4 and I'm going to call this one 5, and then I want to get rid of x's, so I'm actually going to do 4 take away 5, so the x's will go. So 2k take away 2k, they're going to go. Negative 3 take away negative 2, so that's going to give me negative 1z there. And then I've got no k squareds here, so it's going to give me plus k squared z. And 15 take away 14 is 1, q take away 2q is minus q. So what I have here is k squared take away 1z is 1 minus q. So let's just carry that onto the next page. So I've got k squared minus 1z is 1 take away q. Okay, so to get no solutions, we could have k equal to positive or negative 1, which will make this 0 z's, as long as q is not equal to 1. So 0 z's equals something that's not 0 gives us no solutions. So for infinite solutions, we'd want plus or minus 1, But we'd want q to be equal to 1 because that gives us then 0z equals 0, and that means z can be absolutely anything. And for a unique solution, we just need k not to be positive or negative 1, so that we have a number of z's, which isn't 0 z's, equal to something, and we can solve that and find a unique value of z, which then leads us to a unique value of y, and therefore a unique value of z.